All right students, in this video we'll be talking about the rate of change in velocity. Okay, that is acceleration. Till now we talked about what is distance, what is displacement, what is speed, what is velocity, right? Now in this particular video we'll be talking about rate of change in velocity. Okay, there is a new term which is given to the rate of change in velocity, that is acceleration. Okay, change in velocity with respect to time. Okay, that means like you started from like zero. Okay, you started from a zero speed and you reached to the speed of 20 meter per seconds. All right, and then if I'm asking you what is the change in your velocity, that you'll be telling final velocity minus initial velocity divided by t. Okay, time. That means the example which I'm giving you, okay, you are starting from zero, that means u is equal to 0. Okay, and you have attained a velocity of 20 meter per seconds, that I'm telling you. Okay, and then in time, okay, 10 seconds. Okay, I'm telling that in 10 seconds of time, okay, you started from 0 and you reached to 20 meter per seconds of speed. Okay, then what is the rate of change in velocity? Then what you'll write, 20 minus 0 divided by 10. Okay, then the rate of the change in velocity would be 2 meter per second square. Okay, for the unit for rate of change in velocity is meter per second. The SI unit of acceleration is meter per second square. Okay, why is this? Because the unit of this velocity is meter per second and the unit of time is second. Okay, and then what will happen now? Total meter per second square. Okay, now, or you can write is like ms 2 minus, okay, or you can write m like this, any way you can write. Okay, this means it is down, this means this is down, this means it is ms square. Okay, and this means that when you are bringing it from down to up, then what you'll do, you'll make the power minus. Okay, now I hope you got the thing. Acceleration means change in velocity with time, and change in velocity is when you are starting the speed which you started the journey is different and the speed which you are reaching is different. Okay, then what happens, that means velocity is changing, right? When the speed is changing with our time, that means there is a change in velocity, and a change in velocity with respect to time is known as acceleration. Now let us just read this. Just during the uniform motion of an object along a straight line, the velocity remain constant with time, right? In this case, the change in velocity of object for any time interval is 0, and whenever there is in uniform motion, what is uniform motion? You are traveling to a equal distance in a equal second. For example, okay, in 1 seconds, okay, you are reaching 5 meter, you are crossing 5 meter. In the next 1 second you are crossing again 5 meter. In next 1 second again you are crossing 5 meter. This means you are in a uniform speed. That means your velocity is not changing, because see here, if I take the velocity of these 2 points, the initial velocity is also 5 meter per seconds and the final velocity is also 5 meter per seconds, right? And that means there is no change in velocity and you are going continuously there. Okay, when we are considering that you are going continuously, there is no change in velocity because you are traveling equal distance in a equal time. But what if, see, you are traveling like 3 meter in first second and you are traveling like 7 meter in next second. Okay, and you are traveling, okay, you are traveling 5 meter in next second. All right, altogether you are traveling 15 meter only. Okay, but you see the distance you are covering in each second is different. Altogether the distance is 15 meter itself. Here also altogether the distance is 15 meter itself, but here you are taking like you are taking equal period of time to complete equal distance, but here you are taking different time in different, you are completing different distance in a different time interval, isn't it? That means this is non-uniform motion and this is uniform motion. Okay, and whenever we are traveling in uniform motion, the rate of change in velocity is zero, because there is no change in initial. Also u is same. Okay, why is it zero? Because u is also 0 and v is also 0. U means initial velocity is also 0 and final velocity. You see, if I am taking here to here, the u is also 0. Okay, start point is also 0 and the end point is also 0. And again if I am taking from here to here, start point will also be 0 and next point also be 0. It is like uniform motion. We are not talking about the when the object is stopping. We are talking when the object is continuously moving. Okay, now here what happens, you see, if I'm taking u here and if I'm taking v here, okay, that means the vehicle is in the speed of 3 meter per second square, and now it has reached to the speed of 7 meter per second, right? That means now v minus u, there will be something, isn't it? Now if you do if u is 3 meter per seconds and v is 7 meter per seconds, okay, now what you do, okay, here it was not exactly 0. Okay, see, this was also 5 meter per seconds and this was also 5 meter per seconds, and when you are doing v minus u divided by t, what you'll get, 0 by t equals to 0. But here you'll get v minus u divided by t, okay, you will be getting minus 4 divided by time, it is 1 second, that is minus 4, isn't it? Now, all right, okay, no, this is okay, not minus 4 because 7 is in, right? And that's see, it is 4 meter per second square, isn't it? Now see, you're getting some value for acceleration, and when there was uniform speed, you are not getting any value for acceleration. That is only the thing it is talked about. Okay, I hope you got the thing.